Okay, in this experiment we will see how water mixes at different levels, and for that I am starting with a simple water in a glass, and I'll just put a drop of ink in it to see how the different parts of this water mass mix together and interact with each other. So this is red ink, and I am putting just a drop of it. To make the path of the water parts visible, I am just put one drop here, and you see how the ink particles are moving. One is density difference, but it doesn't just straight go down. If the density is more, it could have just gone down and settled at the bottom. But the whole water mass is gradually getting mixed. That means the different parts of water or particles of water, they are in motion, random motion rather, and that is mixing the whole ink. That you have seen, that's one part. Now what we will be doing, we will do a similar experiment with a different glass of water, but I'll do something which you will have to work out later on. I'll tell. So now I am doing this experiment with another water mass, and I'll just put one drop of the same ink in this water and see the difference from the previous experiment. I put this ink in water. The ink is going down, but not in the same pattern as it was going in the previous experiment, and in fact here it is not going in the lower half of the water. The entire mixing is there in the upper half. So the lower half and upper half, they are not mixing together, as if this upper half mass of water is resting on this lower half, and these two are not mixing together. So that random motion of water molecules seems to be confined in two different regions. In the upper portion, that has mixed that ink or spread that ink, but the lower portion is different. Now see what is the difference. I am measuring the temperature at the bottom now, where there is no ink. So there the temperature I can measure, and it is around 26 degrees Celsius. Alright, this is, and then now let's measure the temperature of this upper portion. This is much higher. In fact, the temperature at this moment is around 60 degrees Celsius. The lower part of the water is at 26, and the upper part of the water is at 60 degrees Celsius. So that is the difference between this water and the water that I started with in the first part of the experiment. I have managed to get hot water in the top portion and cold water in the bottom portion. What is happening now? This cold water at the bottom is at higher density. As the temperature increases, the density goes down, and therefore that upper mass, which is at much higher temperature, that has much lower density, and hence it floats on that upper density water, and they are not mixing. Because of the density difference, they are not mixing each other. So that random motion is not enough to counter this density difference. How did I manage to get hot water at the top? It's very simple. You just take this coffee heater and put it in water, and just make sure that the coil, that heater part, is not at the bottom of the glass but in the middle of the glass. So water is heated from the middle, and